All right, so we have series voltage sources, and let's show you a couple of thoughts here. If we happen to have here, 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 and here. So we happen to have a VS1, we happen to have a VS2, and we happen to have a VS3. And they're all drawn in series with each other. So as they're drawn in series with each other, let's see. Let's go ahead and polarize these voltage sources. So if we go to polarize the voltage source, let's do this one more time here. Okay, as we go to polarize the voltage source, short plate is negative, long plate positive, short plate is negative, long plate positive, short plate is negative, long plate positive. Do I have the voltage sources polarized? Yes. Can you draw the arrow underneath these labels, VS1, VS2, VS3? Can you draw arrows underneath each one of these showing which way electron current flows? Is a current flowing to the left? Is a current flowing to the right? So I'm going to draw a line. I'm going to draw a line. I'm going to draw a line. But I'm not going to put an arrowhead on it. I'd like for you to think about which way the electron current flows for each one of these voltage sources.
From left to right?
From the left to the right.
Negative to positive, basically.
It flows from negative to positive. Well, here's the thing. Current does not flow through a voltage source. Current leaves the voltage source and it comes back to the voltage source.
Oh.
So if we remember our definition here, for electron current flow, what did we say? For electron current flow, current leaves the negative side of the voltage source and returns to the positive side. There's no statement here that says current flows through the source, okay? Unlike the second statement where it says current flows from the negative side of the device through them to the positive side of those devices. So devices would be something other than voltage sources. Devices would be your resistors, capacitors, inductors, things of that sort, okay? So the very first statement, current leaves the negative side of the voltage source and returns to the positive side. In this case, I have a negative plate, and the negative plate is on the left side of this. The electricity from flowing for that source contributes pointing in that direction. VS2 points in that direction. VS3 points in that direction. Because if I happen to have this hooked up to, if I were to hook this up to a resistor, like so, these currents would sum here and then come down this way, flow through here, come up and end up back to the positive side of the source this way. So in this particular arrangement, each one of these voltage sources, contributes current moving to the left because the electron current leaves the negative plate of the source. So if all of these are moving current in the same direction, we happen to have a situation known as series aiding. Series aiding equals where multiple V voltage sources move current in the same direction. That is defined as series aiding. And it turns out if each one of these voltage sources, so if each Vs on the left circuit equals 1.5 volts, then Vt for V total must equal to what? What do you think? You got three of them moving electricity in the same direction. Each one's 1.5 volts. What do we have?
Four and a half.
We have exactly what you have in your battery pack. 4.5.
4.5 volts.
4.5 volts, precisely. Okay. That's called series aiding. And if we happen to have this situation, I've just killed my batteries. Can't have a bare wire here. Got to have a resistor. Cool. All right. So I will have a VS1, VS2, VS3 again. Go ahead and polarize these guys. What do you see? Do you see the same circuit? Do you see something slightly different? Andrew, what do you see? All three of these the same as the one above?
I see one of the grounds are backwards. So VS1 and 2 are the same, and VS3 is different.
VS3 is different. So let's go ahead and polarize VS1 and 2 as we did before. This was a negative, this is positive, this was negative, this was positive. But VS3, this side is going to be positive, right? This side is going to be
negative.
All right. So based on our definition from before, where we said current leaves what side of the source? The negative side of the source and returns to the positive side. That's the electron flow model. Based on that definition, which way does VS1 move electricity? To the left or to the right? VS1 moves, I'm just going to draw.
To the left.
Okay, so VS1 moves to the left. How about VS2?
To the left.
And how about VS3?
To the right.
VS3 moves to the right. So do I happen to have, I have multiple voltage sources, but are they aiding, or is there something that is putting a wrinkle in all of this? VS3 is
VS3.
Yeah, it's putting a wrinkle in all of this. So here we have a situation known as series opposing. Series opposing. And this is where multiple voltage sources do not move current in the same direction. Okay, and so the period. So the operative word here is do not move current in the same direction. So two are going in one direction, one's going in the opposite direction. So let's give you another hypothetical. If each Vs is equal to 11 volts, then V total is equal to question mark. Each one of these is now 11 volts. How would I determine my total? So the way we determine the total is, again, very simply, very similar to what it is we've done earlier. We can just simply do a little T-chart. And the T-chart will show currents moving in this direction. and current's moving in this direction.
So you'd have 22 volts to the left and then 11 volts to the right.
So I have 11 volts and another 11 volts, and then on the right I have 11 volts moving to the right. And so what will happen is, in this particular case, what will happen
Do they
is
cross cancel each other out?
they do. They do. So we will have a cancellation of here and here. These cancel. These values cancel, leaving you with 11 volts. In which direction?
To the left.
To the left. So the net voltage, the net result of above circuit will be this. Will be a single voltage source that moves electricity to the left. So here, 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 here. Like so. Here you will have negative, positive, and the direction will be to the left and coming back from the right to the left. Okay, and that's how electricity will flow. And what would be the net voltage on this particular guy? This guy will have a V total that is equal to 11 volts. We started off with 3 of these, each being 11 volts. We won't have 33 volts because 2 are in the same direction, 1 is in the opposite direction. The value of 11 that moves opposite of each other, they cancel each other out, leaving us with a net 11 volts. And that happens to be in the column of moving to the left. So that's your final current. So this is your final.
What would be the purpose to make one like this?
Well, the purpose of this is just to understand the math of what would happen if you put a flashlight battery the wrong way in your flashlight. If you put one battery backwards in your 3-cell battery pack, okay, you're going to end up with something other than what you want because you're moving current in the opposite direction. Now, this is laying the ground for your discussion having to do with superposition theorem. When they're in series this way, they're either series aiding or they're series opposing. In a more advanced circuit, they won't be next to each other. You can't reconcile them this easily this way. Let me draw one more for you in this lower corner since we happen to have a little more paper in here. Let's go ahead and do this. Move this up so I have some space to write on. Okay. So let's go and say here. Okay, 4 cells. VS1, VS2, VS3, and VS4. And the values I'm going to put down on here, VS1 will be 6 volts. VS2 will be 3 volts. VS4 will be 8 volts. And VS4 will be 7 volts. So based on this, I'm looking for a VST. I'm looking for an IT, given that my resistor is going to be, let's say, this is going to be 2.2 kilo ohms. And we want the value of VS total, we want the value of I total, and we want current direction through R. Okay, I'm looking for those things. a value of total voltage, a value of total current, and what is the direction? Is it up, down, left, or right through the resistor? So given this, there's a procedure, there's a process of how we do things. So, Mr. Lau, let me ask you this. Wenbin,
Yeah.
based on what we've talked about so far, what is the very first thing that you would suggest that we do? What have we done in all of these other circuits? What would be the first thing we would do for this drawing?
Do this right.
Yeah, what would we do in this drawing to start our analysis?
Oh, another of the code total.
Yeah, we're looking for a total, but what will help you determine that total? What is the very first thing that will help you determine that total?
Triangle.
So yeah, finding the total is correct. I'm looking for a method. Question goes to Rolando. What would be the first thing you would do?
The current direction, or talking about polarities.
Polarities is the key. In each one of these examples, I always started with the polarities of the voltage sources, here, here, and here.
From negative.
So the first thing you do is you mark the polarities based on the plate arrangements of these voltage sources. First thing. So is everybody clear? First thing you do for any kind of analysis, mark the polarities of your sources. Because we don't know what the polarity is going to be here yet. That's the last thing we're going to determine. But we do know the polarities of each of the voltages based on their plates. So this left side here must be negative. This must be positive. Yes? This must be positive. This must be negative. Yes? This must be negative. This must be positive. This must be positive. This must be negative. Are there any questions as to how we polarize those sources?
No.
Okay. So the first thing we do is polarize the sources. Once we have the sources polarized, Gabriel, what would we do next? What did we do in each of those? We polarized the sources. What was the next thing we did?
Multiply the voltage source.
Nope. We're not multiplying anything. We didn't do any multiplication up here. Question goes to Andrew. What would we do next?
It's Kyle. You gotta find the directions, the direction it flows.
Okay, did everybody hear that? After you mark the polarity of the sources, you then have to find the direction of the sources. Do the directions move where they're series aiding, or do they move in opposite directions? They do not move in the same direction. Well, you got to mark the directions first. So the first voltage source, VS1, wants to move electricity to the left or to the right. Rolando, which way does it move for VS1?
From left to right.
No, sir. It doesn't go from left to right. It doesn't go through the device. It exits VS1. So which way does current move? Which way does current leave this source?
To the left.
Negative.
It leaves from the negative plate. It leaves from the left in that fashion, okay? It's got to leave in that direction. VS2, Pauline, which direction does VS2 flow current? Pauline? Oh, she just here. We lost her for a moment. She's coming back on. Yeah, we can hear you now. Yeah, you're back in. You dropped off for a moment.
You're gonna go behind, or I'm gonna go behind.
Thank you for letting me in. I did get dropped.
Yeah. Okay. So anyway, we're talking about I didn't see that you noticed that you had dropped off for a moment when I asked you the question. So first thing we do in analyzing this circuit was to mark the polarity of the voltage sources. After we mark the polarity of the voltage sources, we then need to determine the direction of current flowing out of the source. So VS1 was determined to flow to the left. My question to you is, which should VS2 flow current?
It should be flowing through the right.
It flows to the right. It leaves here and it flows to the right, like so. VS3 flows out of the negative plate to the left. VS4 flows current out of this to the right. Do I now have not only the polarities, but now do I have the currents, directions of currents? Yes?
Sorry, my
So now
connection's really
we're going to
horrible.
do something similar to what we had done earlier, and that is set up a little simple T chart like so. And the T chart will show current flowing in this direction to here and current flowing in this direction to here. So now we have to write down in the T chart which sources are flowing which way. So the very first one, I have 6 volts that goes into which column, class? 6 volts is in the left-hand column, 6 volts. I have 3 volts in which column? The right-hand column, 3 volts. I have 8 volts in which column? The left, so I have 8 volts. I have 7 volts in which column? The right. Add these guys up. I have 10 volts moving to the right, and I have a total of 14 volts moving to the left. Which one wins? Which is going to be the final value of voltage? My VST is going to be equal to the difference of these two, because the bigger number will subtract the smaller number. The 14 will cancel 10 of these volts. If 14 cancels 10 of these volts, how many volts do I have left over?
4.
Yeah, so 14 minus 10 equals 4 volts. So VST is equal to 4 volts. What is the final direction of current? Is my final direction to the right, or is my final direction to the left?
To the left.
My final direction is to the left. Final direction is to the left, okay? So could I summarize this with a single circuit redraw and show this as a single voltage source, like so, single resistor, and this voltage source is going to be 4 volts, and it is current that flows to the left, down here, here, up here, back to the source, yes? And it is
Yes.
4 volts. Do we have enough information to calculate the current? 4 volts in
Yes.
2.2 k ohms. So let's go ahead and do that. 4 divided by 2200, and your calculated current works out to be, Christian?
I'm still doing it. Hold on. I just grabbed my calculator. So 4 volts
Oh.
divided
By 2200 ohms.
1.81 milliohms.
What's your third digit, my friend?
1.82 milliohms.
Okay. Milli what?
The resistance, right? Milliohms.
No, IT.
Oh, milliamps.
There you go. So 1.82 milliamps. I'll do that in red. 1.82 milliamps. Is everybody okay with that current? And finally, what is the direction of current going through the resistor? Is that current through the resistor going to be flowing from the left or flowing to the right?
Going to the right.
To the left.
Because what's going to happen is going to be
Any other? I've got one vote for left, one vote for right. Do I have a tiebreaker?
Left.
2 votes for the left. 1 vote for the right. I need.
To the right.
Okay, you got 2 and 2, so you got 2 on the left, 2 on the right. There's 6 of you on here. Pauline, what do you think? Your microphone is
I,
on.
I have such a very bad, low bandwidth. I can't even see very well at this point. I'd like to think that it's going left, but
Okay. If you take a look at my little redraw down here, I gave you a clue. This is a redraw of 4 voltage sources combined to a single VST. The single VST was calculated based on currents moving left by those sources, currents moving right by those sources. There was a discrepancy between these two. The difference between these two is my final voltage source. 14 minus 10 gives us 4. It's my final voltage source. In the final voltage source, as the current of the final voltage source is goes left because it is the higher of the two values, I have to draw my negative plate on the left, positive, negative, positive. So this side of the voltage source is negative. That's where the electrons come out. So the electrons come out to the left, come down, and then flow through the resistor, and then back up to the positive side of the source. So the question was current direction, not from the source, because we know from the source it flows to the left. What arrow direction did I draw of current flowing through the resistor in the schematic way down at the bottom?
Right.
Flows
going to
to
the
the
right.
right. And this is fundamental. A very fundamental understanding we need to have in place, understanding how currents flow based on the definition of electron current flow model. Electron current flow model leaves the negative side of the source, returns to the positive side. Did it leave the negative side of the source and then return to the positive side? The answer is yes. And then electron current flows from the negative side of the device through them to the positive side of the device. So this side of the device would be negative, the side would be positive, and it flows from the negative through it to the positive side back to the source. In this instance, the current through the resistor is to the right. Okay? So all of these discussions, Kirchhoff's current law, Kirchhoff's voltage law, and the series voltage of series aiding, series opposing, and how we analyze these currents, and specifically the direction of current flow through any particular device, is important for us to have as a foundation before we talk about superposition theorem. Any questions about this before I start the next section?